Good afternoon, everybody. My name's Charlie Nicklin. I'm Chief Executive of IAgrE, and I'd like to thank you all for joining our February, or shall I say Valentine's presentation. I'd like to welcome Steve Noble from Electro Fit Solutions for our lecture today. Steve has been in the material handling business for over 30 years, working for a variety of different companies along the way. Using his knowledge of battery electric vehicles, Steve has turned his attention to giving used equipment a new lease of life. And this is being achieved by electrifying existing internal combustion engine machines to a high commercial standard. These solutions offer companies ways to recycle and reuse older machinery and allow them a cost-effective route to a cleaner environmental footprint. Just before Steve starts, you're all currently muted. If you'd like to ask questions, please use the chat at the bottom of the screen, and then we'll get you to ask your question in person at the end of the presentation. Okay, over to you, Steve.
Oh, well, thanks ever so much for inviting me along, Charlie and Sarah, and thanks for attending, everybody, today. So I'm Steve Noble. I'm from Electrofit Industrial Solutions, and I'm here to talk to you about the REM Association I'm proud to be the founder of, which has been about 2 years in the making to get to essentially what is a feasibility study. But remanufacturing and electrification of used non-road machinery is what REM stands for. We're proud to have funding from Innovate UK as a fast start project, which just allows us to get going with this feasibility study to develop the project further and just see if it's got any legs in the commercial world. So REM is electrifying your CO2 producing diesel and gas engine powered industrial equipment to save money and help protect the environment. So we believe you can extend the life of your redundant diesel and gas equipment by conversion into electrified zero emission REM vehicles. And REM is a remanufactured electrified machine converted from existing internal combustion power. REM can be supplied on contract hire or purchased with a greater operating life than the equipment it replaces, creating new opportunities for UK industry and leaving a greener, cleaner footprint. And the REM Association aims to facilitate simple and safe adoption of REM vehicles. So the stage we're at is stage 1, so feasibility study, which is for the REM Association standards, and also a prototype cost calculation tool, which I'll talk to you about a bit more later. So we've then got stage 2, which is identify and build a physical REM machine, and also obtaining more data and accurate inputs for the calculator. I'm not quite sure, stage 4 has managed to click into stage 3, which working web-based calculator with final calculation costs and recognition and accredited REM standards is basically the final stage. So extending the life of your redundant industrial machinery, so increasingly high costs in running internal combustion machines, particularly forklift trucks, and greater availability of competitive zero emission electric powered alternatives is now causing supply chain issues. There's a high risk of the redundant ICE machinery and forklift trucks being scrapped and then at best recycled. With REM, we aim to create a standard that use these redundant ICE machines and upcycle them with accreditation and warranties to match and to be as good as new. Ownership via a contract hire, outright purchase, or your own specific requirements. Now the benefits are, we reckon, a 20% reduction in total cost of ownership, and that includes 20% less for the actual machine, with a potential to retain over 80% of the embedded CO2 emission from original manufacturing. So with the rising costs and increasing burden of higher taxation, forklift trucks and industrial machinery costs are increasing disproportionately to companies' profits, and in many cases increase of over 200% just in the last 18 months. The lowering cost of lithium-ion electric alternatives and their inherent reduction in running costs has greatly increased the demand of these electric alternatives. So the increased demand, coupled with global supply chain issues, has pushed lead times of up to 90 weeks, resulting in foreign exchange rate increases and increased risk of management of the finance contracts that sit alongside much of this product. The reduced demand for ICE machinery would also cause an influx of redundant used equipment. So with the original manufacturing energy, if this is wasted with the machinery being scrapped and by them not being reused, we believe that's a complete waste, where we can help retain 80% of that original material and save that energy, reuse it, and improve the commercial viability of this type of vehicle to asset management companies, AMCs, and also to their customers. This project will also improve the UK's position as a leading net zero country, and in turn create new jobs in the REM marketplace. Now, we know this is possible, and I personally know this is possible because my father was doing this back in 1977 and had a small factory that was remanufacturing Alice Charmer, Caterpillar forklift trucks, taking out the control systems that were in there and the batteries, and stripping them back to their bare chassis, checking the structural integrity of the machines and rebuilding them with the latest control systems. To give you an idea, the latest control systems back then was thyristor control systems. But then what I watched as time's gone by is that it's been so much cheaper to produce new that it's just become unviable in most instances to remanufacture. So we're in favour of going new because it's cheaper, and so our aim is to actually drive the costs down of doing what we used to do. So the aim of this section of our project is to produce a prototype cost calculator, which is affordable and adaptable and investable, to evaluate the feasibility of REM. So before any companies spending money on developing an electric remanufactured product, we want a cost calculator there. And that's what our aim is, to give a cost calculator so that they can, before they've turned a spanner or a screwdriver, evaluate whether it's worth actually carrying out the process. We then want to assist companies in reducing the legal risk of carrying out the conversions and or of owning REM vehicles, and also assess the feasibility to set up a new trade association, which will help form a clear route to the market. So the objectives then are to produce a clear set of standards that are in line with current regulations and legal insurance requirements, to work with asset management companies and use physical examples of forklift trucks to practically evaluate the criteria required to input into the computerized model. Reason we're saying forklift trucks is what we know at the moment, so we're hoping that that will expand to much more, a much wider sector of industry. And we want to obtain the component requirement pricing from battery and part manufacturers to establish data for accurate inputs into the calculation tool, again to save people more time and allow them to get on with what they do. And we want to progress this from the concept, which is what it started out of, to the cost calculator prototype. So this is from technology readiness level 2 to technology readiness level 5. And so what does a REM conversion look like? Essentially, this is a short video just showing an engine forklift truck that this is a standard 2.5-3 ton counterbalance forklift truck that one of the manufacturers back in about 2017 decided to look and see if it was suitable to use as the basis for a new forklift truck. So they simply took the engine out and all of the additional componentry that was required to run an engine in a forklift truck. And this is the electric transmission and motor. And so this is then put in place of the original transmission, and with the motor being much denser and smaller, it's able to be mounted very low down in the chassis. So in the situation of a forklift truck, this is a really positive thing, because we want a low center of gravity, because forklift trucks are inherently unstable, as maybe some of you have found out, lifting loads at height and trying to turn on gradients. So then with the battery, also a small compact lithium-ion battery pack with the battery management system installed on the side. Everything's very accessible, but it's also very compact, which means that we can keep that center of gravity and the load centers exactly where we want them. And this is the process finished and going away for testing on the load ramp. And so that was a diesel machine converted into electric, not remanufactured to an ASNU standard, but gives you an idea of the feasibility and the ease that it could be done. Now we know this is happening in several other industries. I'm going to talk to you about a purpose-built electric ferry. Now, this particular ferry called Ellen has been in operation since 2019. It was purpose-built, but it's been operating between 2 Danish islands, and it's saving 2,520 tonnes of CO2 emissions per year. It operates at 85% efficiency from grid to propeller. They believe it's going to be anywhere between 4 to 8 years return on investment. With a REM equivalent, it would be even faster. Now, the 2,500 tonne of emission is what they're actually saving using renewable. If they did have to use the Danish grid to power it, it's still going to save over 2,000 tonne of emission per year. And one of the big questions is with electric vehicles versus IC is always, but the cost of producing the battery is so high, and there's such a high cost environment, where they've actually done the study on this, and it was 215 to 430 tonne of CO2 emission in producing the batteries, and that's estimated to be about 3 months of the very best modern diesel ferry. So the CO2 emission payback is 3 months, and that's equivalent really with cars. There's studies to show that an electric car is returning investment on CO2 emissions in about 6,000 to 7,000 miles, depending on the vehicle and the efficiency. And in this particular instance, the recharge time on the ferry is 20 minutes. So a charging arm comes down when the shore ramp it comes down to allow the vehicles to disembark and embark, and it recharges in 20 minutes. So basically the time it's taken to load and unload, they're ready to go again. And in Europe, it's estimated that marine traffic is responsible for 12% of CO2 emissions, and that's almost as much as all the passenger cars in Europe. And globally, the routes are now in process of electrifying. So with conversion of existing diesel powered ferries to electric now becoming sort of viable due to the significant savings on running costs. So an all electric ferry can cut emissions by 95% and operating costs by 80%. A REM equivalent ferry, the return on investment would be much quicker, but the emissions would probably be, they won't be quite as efficient as an all-electric purpose-built. And we know the REM is already happening. There's a company called Lunas that some of you may have heard of. It's set up in 2018. They restore and convert electric vehicles. With luxury cars like Bentleys or Rolls Royces, Land Rovers, Range Rovers, and they're expensive. But what they've done, David Lorenz and also John Hilton, who's the MD, and I've spoken to extensively, they've used that funding to develop refuse upcycling. So with zero waste and zero emissions, Luna's Applied Technologies has been formed, and they've introduced their first commercial upcycled electric vehicle. So they call that the UEZ. They realised that the potential of upcycling to plot a more sustainable path to a decarbonised future was in using what we've got. And Luna's remanufacture and technologically upgrade refuse trucks. They're producing a sustainable product without any functional compromise at all. In fact, it's a better product than what it replaces. And there's a study that they've had carried out, an independent audit, and they're actually saving, they say, up more than 80%. It's actually 83% of the embedded carbon by remanufacturing a refuse truck instead of buying a new one. And one Luna's factory is actually preserving the equivalent weight in CO2 as the Eiffel Tower every year. So one of your own members, Richard Robinson, was very kind to speak to us about a project that he looked at in electrifying one of his rollers. And basically they do this, sounds similar to the forklift truck industry, where the lifetime of the product can be extended. It's very solid, heavy product, and you can refurbish or remanufacture them. But he looked at actually electrifying one at the same time as refurbishing it, but hit across several stumbling blocks. One was the battery cost. Another was the lack of a durable oil-free power steering solution. And another was achieving the variable speed control to give similar characteristics to hydrostatic. But Richard did consider that it's going to be possible to achieve electrification in the future as technology improves and cost of components lowers. Now, interestingly, Richard's also involved in a ferry project, an electrified ferry project called the YCET, which is the Yelm Community Electric Transport, which is a small electric ferry or taxi, which takes yachtsmen and local and walkers along the River Yelm. And I just felt that it shows a lot of synergy, the fact that big ferry companies are electrifying, and it's even coming down to smaller ferries and transport vehicles. And looking at some of the products that Autoglide, Richard's company, do, there's certainly some candidates in there that we could look at to study for REM electrification and remanufacturing, and we'd love to help with any projects like that in the future. And again, one of the areas that we're finding with remanufacturing is that most people just aren't aware of it. And we came across this article, which was from Whatcar, that they actually studied the remanufacturing of approved cars, and only 16% of people in a study they carried out of 903 people, they actually understood what factory refurbished or remanufactured was. But after it was explained to them, 55% would prefer to buy refurbished used over an approved used. And 63% said they'd pay the same or more for refurbished versus approved used. And over a third would consider keeping their current car longer, knowing that they could send it to a factory to have it refurbished with new components if and when that time came. And what also researched that buyers would rather go for remanufactured, and most in-car market buyers would be interested in manufacturer OEM refurbs rather than standard approved used. And on this basis, Renault and Toyota have already introduced manufacturing of refurbished or remanufactured programs, and vehicles are being taken back to their factories for retrofitting with new components and or upgraded parts. And one area this helps the manufacturers with is basically meeting their environmental targets. So I think this is something we'll see more and more, and it's probably going to become more apparent to all of us that the government are going to find a way of taxing us on what we emit rather than what we use, or as well as and looking at in particular the agricultural community and irrigation pumps, and just looking at potential ways of electrifying and using what we've already got. There's less emission and more energy savings using an electric irrigation pump, from what I understand, than using diesel. And there's a good potential for conversion because it's a fairly simple product. So Danfoss have been fairly prolific, especially in drought-stricken, sunnier areas, in making this technology work. So I know we're not always blessed with the most sunshine, and we have a fair amount of rain, but it is becoming more and more imperative that water usage and water-saving irrigation technologies are more viable. And on this basis, to optimize energy costs and pumping, it's essential to ensure a long-term economic and environmental sustainability. And so then we're looking at what types of vehicles are suitable for REM conversions. So one that we've identified at the moment in the top left-hand corner of my screen is the forklift side loader, with REM as a high potential as a prototype. Then we're looking at excavators as a potential, slightly more complex, but again, potentially viable. What we found is, providing the value of the new equipment is around about £100,000, there's the potential for it to be viable. Anything less than this at the moment, it's not commercially kind of easy enough to do, because the costs start to get in the way too much. So on that basis, same as with the smaller forklift truck, it's not commercially viable right now because there are too many cost-effective competitors out there producing new for less money. With tractors, it's possible. John Deere are doing it as a new bespoke product, but due to things like run times, some of these when they're running, there's not necessarily going to be the opportunity for brakes to charge them. So that's where we need to let technology and our understanding catch up with us. So why are we so concerned about remanufactured and not recycling what we've already got? Because basic recycling sounds fantastic, but it does use a lot of energy, and as steel is such an essential part of our modern life, and it's also crucial for us to move on with the future. But the problem is that steel production still, even with recycling, is one of the world's most polluting industries, accounting for as much as 9% of direct emissions from fossil fuels. And that's more than all the world cars and planes combined. Even though 70% of steel produced to date is still in use, and using scrap steel instead of virgin ore reduces CO2 emission by 58%. And recycling can save up to 1.67 tonne of CO2 emission. It's still in 9% of emissions. So we need to find better ways if we're going to do what we're told we need to do, and what we probably in most instances know we need to do. There's much conflict in data regarding steel production, and this will form one of the next stages of our project, is that we want to understand what a new product actually costs in CO2 emissions to produce, what a REM vehicle will cost in CO2 emissions to produce, including all the supply chain to get that to us, and then look at what using recycled materials actually costs, because I'm seeing it's 7.9 grams per ton per kilometre, and I just don't believe it, because by the time we're shipping some of this to China or India for recycling, I don't believe the figures. So I would like to get to the bottom of that with the right people, with black and white data that we can embed within our cost calculation and CO2 calculation tools. And onto the tools. This is being created by Brighton University. I've got another short video to show you which Brighton University have been kind enough to create for us. So I'm going to play that for you now, just to explain what the cost calculator is and what it's hoping to bring.
Hi, today I'm going to demonstrate for you the total ownership cost calculator. As you can see here from the landing page, consumers will be able to choose one of these three scenarios based on their situation, and it will give them a 5-year total ownership cost to give them the chance to make a better informed decision on which path to go down. The three scenarios are buying a new electric vehicle, utilizing the trade-in value of their existing owned one, or if their current lease is at an end. The second scenario is buying out or renewing their existing lease, having the vehicle remanufactured to a like or better than new state, and continuing on, thus still having an internal combustion engine. And the third scenario is remanufacturing and converting their current internal combustion engine vehicle into an electric vehicle. The user, once choosing a scenario, will be directed to its personalized page, where the user can then enter in their personal details as well as details about their current vehicle. They can then enter in the estimates given by the dealer, or consult the prices that they're already paying for their current vehicle and enter them all in here. Once doing so, the calculations will be updated on the side here, giving them a breakdown of the 5-year ownership, total ownership cost, as well as just a small overview of their capital and operation costs. The same goes for each of the two other scenarios. When entered into those individual pages, different variables become available to be filled in by the user. What you see before you is the first stage of a two-stage process. The second stage will be creating a database of the current vehicle information that the users input. This information, alongside estimated trade-in values as well as remanufacturing and electrification values, will create a database that can be used for future estimations by both consumers as well as those in the industry.
So next stage of REM, as part of the stability and structural testing, is that these machines will need to comply with the same load safety testing as a brand new machine. So they'll go through the same thorough tilt table and inspection testing, with all of the structural welds being inspected, crack tested, or using more modern techniques which are available now to ensure that all the welds comply, and if they don't, that it's re-welded, and so again to as good or better than new standard. And that goes the same for the EMC, the electromagnetic compatibility testing. But one thing what we can do above and beyond a manufacturer from new, is that we can actually do pre-compliance testing So we can actually look at individual components that are going onto a new vehicle and then help reduce the risk of failure when the full vehicle is tested, which can be an expensive process. So it helped reduce some of that risk. And another thing, as part of the association standards, will be a recognised either kite mark or ISO standard that will give assurance to anybody that's buying a REM vehicle that it does meet that standard, so that it's remanufactured and returned to as good or better than new, with the equivalent or better than warranties than the new product. And also a confirmation that this is actually helping to build a more sustainable procurement future, which will become more and more of an incentive, providing the prices are where they need to be. And there's also the insurance and legal protection, which is not just for the end user, but it's also for the companies that are actually carrying out the work. So if a company is carrying out work to REM standards, to an association standards that are approved, that they are covered, that the REM association standards are covered and approved, and that we have insurance to safeguard ourselves and anybody that's following the standards, to help protect the end user and individuals and the companies that are involved in the process. What are the benefits for you as members of the REM Association? So as well as being a member of a greener and cleaner community, which, although it sounds a bit fluffy, there's a lot of commercial positives to that, because just by being a member of an association which is looking forward, we find better ways to do things commercially that help save us money and make things more efficient. There's also measurable net gains. So there'll be added authenticity for any company's greener credentials that take on or carry out REM production. There's also lower cost of product with a much quicker return on investment, and also greater availability of electric mobile machinery. So we'll reduce some of the lead times. And also with more choice in the variety of solutions that are available. So some of these products that they don't make anymore, that actually solve a lot of our problems, rather than manufacturers telling us we can't have it, we could maybe look at remanufacturing what we've got to an as new standard and get the same warranties as we had when we bought it from day one. So this does create a lot of opportunities. So as well as improved profitability for machinery sales, there's the reduced lead times for electrically powered machinery, the use of a calculation tool to help protect profits when evaluating redundant ICE machinery, and also a set process to follow. So it takes a lot of the guesswork out. And then there's protection with the association standards. So we're looking to take away some deliverables from this, which is a minimum viable product of a prototype web-based cost calculation tool, which you'll get to see when you watch the video back, which is dedicated to REM vehicles and machinery, a framework for recertification for REM vehicles and also continued development, and a market survey report completed by industry, vehicle and machinery operators, and 2 workshops with an online one, which we hope this to form part of the first one, to gain feedback from participants. And our aspirations are to facilitate the upcycling of existing ICE industrial machinery, and enable customers to make better decisions when purchasing replacement industrial machinery, and create a safe framework in which companies and AMCs can operate REM industrial machinery. and supply a simple online calculation tool for fleet buyers and AMCs to evaluate REM, and provide the support and the structure and consultancy for fleet buyers and AMCs to make the right decision when disposing of redundant ICE machinery. So the REM group and the REM Association have been supported by Remade Group, and Remade Group are facilitating in upcycling and circular economy practices. They have a platform which is dedicated to the sale of remanufacturing products. So this is a route to market for REM products. They have an e-marketplace that they're building, which allows us to put products on not just finished machines, but also components for machines. And they have a whole process which is recorded by blockchain, so that there's no way of bypassing the system once it's in the blockchain. As well as having a way of recording how we did things, we've also got a way of safeguarding how it was done. So for warranties or anything that's going wrong, there's a secure way of locking in that process of individual as well as the whole system and process. Now, to give an idea, there's a huge growth potential in remanufacturing. In 2021, it's believed to be 5 billion, 25, 10 billion, and it's believed that it's going to grow to at least 15 billion by 2030, probably more. And the Remade marketplace is there to create a permanent record of, as I was explaining, of the processes, and it underpins the quality for buyers. So again, they can have confidence in what they're buying. Where have we got to and what next? So we're virtually at the end of stage 1 now, and we're now going on to stage 2, which is to build a prototype, which will then allow us more accurate inputs into the calculation tool. And we will have a physical side loader forklift truck at the end of that process, which is 18 months away from the start. So we'll probably be starting in June, fingers crossed, and then we'll have more to report. And the important takeaway from this is we don't have all the answers yet, but by working together, we can find better ways to use what we already have to build more sustainable circular economy for everyone. So how can you help? If there's any assistance, any feedback that you can give, we greatly appreciate any input. Invite us to discuss and process, evaluate anything that you'd like to look at in conversions, and help us just by making sure we've got a simplified way of evaluating these complex variables. So your product knowledge would be invaluable, and then contributions and questions to cover all aspects of what we're formulating in these approved standards. And if you can see that it does add value to your particular industry or your sector, any support letters which would help us gain additional funding would be greatly appreciated. And if you could complete the 10-minute survey that Sarah will be sharing, just to show you, understand your views on REM and where you see us, again, would be fantastically appreciated. And thank you very much. Very sorry for the hiccups. Please visit our website, rem-org. That would be great. And thank you for your time.
Okay, thank you, Steve. So we've got a few questions. Craig, do you want to start?
Sorry, I didn't realise I was being put on the spot there. So I thought it's in the chat. I can leave it to somebody else telling about it. I can't remember. Yeah. We are, I'm involved with the digital displacement pump at Danforth, so CO2 emissions are big on our agenda. But I don't know if you, when you do your calculator, do you work on the basis of just the emissions from the diesel engine, or do you talk about well to wheel, you know, actually extracting it out of the ground and getting it through the process?
Exactly, that's exactly it. It's the complete process. We don't want the, because when we look at fuel companies saying that the emissions from a car are X number of grams per mile per kilometre, the fact is it doesn't account for what it takes to get the fuel out of the ground and into the petrol pumps, and it just accounts for what comes out the exhaust pipe. We don't want that. We want a true calculation.
Okay, yeah, you're going the right route, so you just wanted to check that you're taking the same path.
Yeah, it sounds good. Yeah, it sounds good.
Yeah, okay, thanks.
Thank you.
Okay, Brian Matthews.
Steve, thank you very much indeed for that. Really interesting. My little question was just a personal one, really. Owning an old Series 3 Land Rover, and wondering what the cost of converting something like that would be, either as a do-it-yourself, or if one was to get a company to do it.
I mean, it's a difficult. I believe Luna's charged in the region of about 120, 150,000 pounds, but they do a fairly full-on conversion. I think they do 0 to 60 in God knows what. So but there is a company called EV Parts that we are working with, and they can supply the drivetrain, the batteries, and they can help. They're good at prototypes in particular, but there are some specialist companies. But I think realistically, again, at the top of my head, you'd be looking at, to do a decent job, I would say probably 50,000 if you were piecing it together with the right people, but not doing it completely by yourself.
Right. Okay, thank you.
That's okay.
Okay, Bob Pringle.
I think my question has maybe been answered by Brian, in that I just feel that there may be, to keep the labour costs down, there must be an awful lot of DIY people who love their cars and would quite happily buy a kit, as long as there was some way of asserting that it was done to the proper standard.
It's quite, that is very, very much true. It is possible to do it, and there are DIY. EV Parts are one. There's a couple of companies up in Wales that do this. On the top, the name sort of like it is just not coming to the tip of my tongue right now. But yes, it is possible. And I believe with cars, it's actually much simpler than with industry in a lot of ways, because with cars you can electrify, and providing its weight complies with the weights of the original manufactured vehicle, all you have to do is then apply to DVLA for a change of power, and then you don't need to actually do that much. It needs to pass its MOT, obviously, but you don't have to, other than its MOT. From my understanding, talking to the car vehicle remanufacturers, that's what it needs to happen to. Ideally, you want a record of your build of the vehicle, but yeah, it can be done. And again, they're things that we hope to sort of promote and bring to the market more and more, because what we find in industry, people have probably got far more ability to do it than the general public. So if you have got these vehicles, there's going to be a much better uptake and possibility of it happening, and we can save some of these lovely cars and keep them going.
Thank you.
Okay, and then last question, Mark Andrews.
Hi there, Steve. Sorry to go to a technical question. I'm heavily involved in the electrification of tractors and earth-moving machinery and road vehicles from a new perspective, and it is very bureaucratic, and there's a lot of safety involved. With such fundamental changes to original machine, who is your intention? Who will be overseeing the compliance aspects for these machines? Because they're going to need it to comply with the latest regs under UKCA, CE marks. It's going to need a technical file. It needs verification of the safety related parts of the control systems and all this. Who owns that? Is it you, or is it the OEM?
No. That's a very, very interesting question, and it's probably one I'd love to talk to you in more detail afterwards, or a later date. But essentially, what we need to do is make sure that we comply with, and we don't change the original manufacturer's structural design. So that's the first thing. So we work within the original manufacturer's structural design and drawings. Secondly, we keep the weights the same. Thirdly, we do then need to carry out the EMC testing and the stability testing. But this is one of the areas where it's an absolute rabbit warren of paths to go down, because we're looking at this from a UKCA marking perspective, and we don't expect to be there for probably 3 years, but that's the route we're going down with this, and we expect to be able to comply with UKCA marking. And that's what we're going for. So, and as you better than I probably know at this stage, that is an absolute quagmire to get through. But I would love to talk to you, Mark, a bit more on that. Maybe next week when I'm back and I've got a bit better internet.
Yep, certainly. Obviously, I mustn't have any conflicts of interest, but yeah, I'm very happy to help where I can.
Perfect. Oh, thank you.
Okay, we've probably got time for one more question. Rupert, do you want to ask yours?
Hi there, Charlie. Hi, Steve. Thanks. Very interesting talk. Sorry, I just dived a quick question in there right at the end, just as I could tell you were trying to probably wind up there, Charlie. But yeah. So my question is, if the vehicle's got hydraulics, like a forklift or a digger or something like that, do you and the engine obviously drives the travel and also hydraulic pumps, do you look at just putting in a appropriately sized electric motor to drive those existing pumps to work the existing actuators, or do you look at in some cases direct electric actuation of the steering or mass or whatever the hydraulics currently works? I suppose it depends on power density and available space.
Totally. I mean, what we're looking at in the first instance as a physical build prototype is actually taking a hydrostatic drive machine with hydraulic lift on it, and actually removing the engine and basically replacing the engine with the appropriate power source motor, and powering the pump unit. And so, and although it doesn't give you the efficiencies of a direct drive electric motor, when we're looking at costs and longevity of machine, we're retaining much more of the original equipment for not such a massive drop in efficiency. So that is our first instance. Whereas originally we thought hydrostatic was going to be an issue, it's actually a real good opportunity to use more of what's already there, rather than having to take out things like transmissions, as you say, pumps, yeah, we would use as much of what is already there as we possibly can.
Okay, yeah.
And obviously testing and replacing sort of anything that's necessary. You know, hopefully this is where we can kind of reskill some of our workforce and some of our youngsters coming through for some of the old practices of actually remanufacturing things like pumps and and hydraulics and hydrostatics.
Okay, yeah, no, that's great. Thank you.
Okay, well, we're just on an hour, so I'll draw it to a close. So thank you, Steve, for the presentation there. Very interesting. Thanks for doing it while you're on holiday in France. That's very much appreciated. I'm sure everybody found it interesting. So thank you everybody for joining us today, and I hope you will join us for our next lecture on the 14th of March, where we'll be joined by IAgrE member Mike Whiting from Newmac, and Mike's going to be talking about some of his experience in guiding people through machine safety systems. Okay, so all that's left to say is thanks again for everybody joining, and we'll see you next time. Bye-bye.